Good day to our dear panelists. I am Christian Tan, and on behalf of Hans Ramos, Patrick Simpao, Ricson Vergara, and Dr. Joel Ilao, I am proud to present to you our research study entitled Cipher, the integration of computer vision technologies in monitoring of overstaying bus vehicles in EDSA Carousel route bus stations. In the context of the Philippines, public transportation is seen as a rudimentary aspect of every citizen's day-to-day life, as it serves as the main mode of transportation for majority of the population. And on this note, specific government branches such as the Metropolitan Manila Development Authority, or MMDA, and the Department of Transportation, or DOTR, are formed, assigned with the responsibility to ensure that the flow of traffic will be orderly and every Filipino commuter's experience would be seamless as possible. Due to the pandemic, abrupt changes were needed to be undergone. Relating to public transportation, one prime example of these new implementations is the EDSA Carousel bus stations. So subsequently, a new traffic scheme has also been applied to regulate the flow of vehicles in the said location, and that is the bus staying time rule, stating that when a bus stays at the loading area of the station for more than 1 minute, it will be flagged as overstaying, which then would incur sanctions to the violating bus company. In the short lifespan, issues already rooting from its manual implementation have risen, such as undetected violations and inconsistent violation detections by the personnel on duty. With the dawn of technological breakthroughs upon us, it is only fitting to integrate the existence of such innovative tools into our everyday tasks and let alone governmental processes. In lieu of this, one specific field of technology stands out in terms of its high potential ceiling that it can offer when it comes to human-centric use cases, and that is computer vision. Computer vision is a field of artificial intelligence, or AI, that enables computers to derive meaningful information from digital images, videos, and other visual inputs. Using this as its core, the group aims to create a system that is capable of automatically detecting overstaying violations and be able to produce data visualization from the gathered data, which will enable the authorities to generate significant insights. The objectives of the system are to address the aforementioned issues, and as well as to reduce the manpower required in the field to monitor the violations, maximize the capabilities of already existing CCTV cameras along the target locations, and be able to provide significant insights based on the raw and processed data collected by the system through data visualization. So the system integrated two main computer vision algorithms, namely You Only Look Once, or YOLO, and the simple online and real-time tracking with deep association metric, or deep sort. So YOLO allows applications to detect objects from a given image by setting a bounding box around the object and then identifying what object type is it. Deep sort, on the other hand, is a practical method for multiple object tracking and is utilized by the project team because it is able to track objects longer over an extended period of occlusion. Moving on to the methodology, the design system has three main modules, namely the data preparation, the detection, and the visualization module. By developing the system in a modular approach, it becomes more adaptive to possible changes in the future. So shown in this slide is the design architecture representing the process flow and components used for the system. The first step of the process flow is the data preparation module, where there will be an option to cut the footages into chunks of 5-minute shorter videos using OpenCV, which is a computer vision library, and FFmpeg, an open source library for video processing. Cutting the footages into shorter chunks allows the system to process them in a shorter amount of time and also consuming less resources. Then after this, the user will have to upload the videos to be processed by the detection module. This stage is where the data would be produced, which then will be stored to a cloud-based database named MongoDB. After the processing of the video, the visualization would be next, wherein the website interface will fetch the data from the database and use them to create graphs and tables using the charts.js library. It is also worth noting that the overall accuracy of the system will not be improved in the development of the project, as it will be heavily be dependent on the accuracy of the specific computer vision technology used. Next would be the discussion of the results. For the main feature of the system, which is the overstaying violation detection, buses are detected once they have entered the region of interest, or ROI, within the carousel, which is represented by the darker shade of color as seen on the screen. They then will be tracked up until the time they leave the frame. On top of that, data such as the date, the time entered, the time left, the dwell time, and status of all the detected buses are saved into the database. Buses that stay for more than 1 minute on the region of interest will have their status changed to overstaying, indicating that they have committed a violation. Aside from overstaying violation detection system, the project will also include a website dashboard in which authorized personnel will have access to. So this dashboard will include the data visualizations of the information produced by the detection system in the form of charts, tables, and summary cards for the user's reference. Then, in order to validate the results of the detection system, the researchers opted to perform a manual counting of the buses and all of the test footages, which includes 3 whole-day videos of the main avenue station of the EDSA carousel. After that, the system itself also processed the same set of videos. The results of these were then tabulated into a histogram, which is presented on the screen. So as we can see, there are some discrepancies between the data gathered from the manual versus the automated bus counting. The manual counting resulted to a total of 2,989 buses, while on the other hand, the system was able to detect 3,005 buses. For the overstaying violations detected, the manual counting was able to pinpoint 318 violations, while the system was able to determine 295 cases of overstaying violations. So these differences may be attributed to misdetections in the system that can be caused by some challenges such as viewpoint variation, occlusion, illumination conditions, and cluttered or textured backgrounds. The system is also capable of detecting buses in nighttime, given that there's sufficient lighting that will enable the system to clearly see that the bus indeed is an object of interest that would be inside the frame of the video. In conclusion, data provided by the system can help the MMDA improve in its management of the EDSA carousel. The system will be able to provide an on-the-ground traffic information for crafting better traffic management policies. By utilizing the web dashboard, MMDA will also be able to gain valuable insights regarding the day-to-day operations of the carousel. Then, in terms of accuracy, a difference of 0.53% is present in terms of the bus detections, while a difference of 4.96% in the violations recorded are present between the system and the manual generated data, which can be attributed to multiple factors such as the video quality, lighting conditions, occlusions, and the viewpoint variation. Then for the future iterations of the project, it's recommended to further enhance the capabilities of the system in order to cover other types of vehicles and also to cover the other terminals along the EDSA carousel. The research group would also like to acknowledge the study's project partners, which is the MMDA and DOTR, for their continued support for the team and for their provision of the needed resources all throughout the duration of the project. We also would like to acknowledge the Titan team for sharing their expertise in the field of computer vision and for guiding the project group in the development of the system.